Greetings, my name is José Pedro, and my project revolves around using virtual reality towards 3D complex imaging in a use case that represents air pollution.
As we move towards a society that's becoming more and more overloaded with information, the need to process huge quantities of data increases accordingly. This requires innovation in fields that deal with representing and processing these huge datasets, like the scientific visualization one. Having more dimensions of information being added, new creative and intuitive ways of representing information must be found. This is where virtual reality shines, as a rising technology that allows us to have more immersive options and navigation, providing new ways to interpret and understand information in ways that weren't viable before. Immersing a user in a virtual environment not only increases his perception of the environment, but also allows more natural navigation and interaction, offering possibilities that weren't possible through desktop visualizations. Here, we have a dataset composed of around 63,000 lines per file, each containing a pair of coordinates along with details regarding NO2 pollution concentration and wind information for that fixed point in space. There are 24 of these files, each corresponding to an hour of the day. Attached to these, we also have files with coordinates that delimit each building of the urban area in representation, situated near the city center of Porto, in the north of Portugal. It is then our aim to build an urban area model of the area with information regarding the pollution represented on top of it, in the most intuitive and clear view possible. To achieve this, we firstly use the visualization toolkit in its Python wrapper, commonly referred to as VTK, a well-known software in the scientific visualization environment, to develop two different representations of our data. The first visualization included the pollution concentration as well as the wind direction and velocity for each point in space. The second focused solely on visualizing the NO2 concentration per coordinate, representing every point on a 2D image that was placed underneath the model. We added our navigation and a legend to help understanding the data. After this, we aim to integrate the VR component of the visualization. After investigating on the currently available tools to integrate our project in a VR environment, we decided to use OpenXR, a recently developed module designed to fit on top of most and every platform and engine. Integrating the OpenXR in VTK allowed us to render and present the previously created scene in a VR environment, after some adjustments. This interactive experience permitted the previously mentioned qualities of VR, thus being limited in part when compared to the desktop versions, due to software limitations regarding lack of function mapping on the side of VTK. Nevertheless, we were able to navigate our scenes and get a different grasp of the information. Then, we decided to try a different method, using Unity, a game development engine well known for its easier VR integration and multitude of diverse projects. We made use of an asset called ActiveEase to render VTK scripts in Unity, which enabled us to represent the data in the same way as VTK. After that, a VR interaction rig using OpenXR was built to adjust the environment to VR, but unfortunately, it was impossible due to render incompatibilities between ActiveEase and OpenXR. In conclusion, the exploration of virtual reality for scientific visualization of large datasets, such as this one, demonstrates significant potential despite current technical limitations. The integration of VR with tools like VTK and Unity offers promising ways for immersive and intuitive data representation, enhancing user interaction and comprehension. Although challenges such as software compatibility remain, the progress made emphasizes the transformative potential of VR in handling complex datasets. As technology advances, these hurdles are likely to be overcome, paving the way for more sophisticated and accessible data visualization techniques that leverage the full capabilities of virtual reality.